Compounding interest is another form of interest equation, one a little bit more closer to what banks might use. And the reason for that is because compound interest is talking about interest that's being applied to account multiple times. Now, we can compound that interest in a few different ways, and some of those ways are listed here. For example, annually means once, semi-annually, obviously, twice. Quarterly would be 4 times, monthly 12 times, daily 365. We also can have things like weekly, which would be 52, and then of course you can get into bi-weekly or anything like that, and basically break them down as far as you need. Now, compound interest is a little bit different because it has a different setup. Here, when we talk about A is going to be the amount accumulated. So when you're looking at your, say, savings account, the A value would be the amount you see maybe at the end of the month. Most of the times your banks accumulate interest on a monthly basis. At least that's the norm. However, obviously it can be done a lot differently. And the A is the amount that you see after your interest has been compounded a certain number of times. P is still your principal, R is still your rate, T is still your time, and again, it's still always in years. But here we have this N value. N is the number of times you are compounding throughout the course of 1 year. And that's what these definitions all meant. These definitions mean the number of times that bank is going to compound or calculate the interest owed into your account and put it into your account. Okay. So what I wanted to do was show you just a couple quick examples on how this new formula works so that you can see how to calculate your own compound interest problems. So here I have that you borrow $4,000 to make a purchase and will pay 8.8% compounded semi-annually. The question wants to know how much will you pay for the purchase after 4 years' time. So we have to look at what we've been given. Well, first, P, or the principal amount, is going to be the $4,000. That's the amount that I borrowed. The R is your rate, which is 8.8%. Your N was semi-annual. So if you look, semi-annually means 2, so that means twice a year. So N is 2. And then my T is 4 years. Now again, just like with any other interest problem, your rate must always be changed over to a decimal. So when we're talking about your rate here, we would take that 8.8% and divide it by 100. Gives you 0.088. Of course, you want to use this decimal in its entirety. Do not round. So in other words, 0.09 is a much different value than 0.88. Okay, so use what you've given. So now we have to put it all together, and if you notice, the one variable that's missing here is the A. This is the part that we don't know. So my A is going to equal my equation, which says P times 1 plus R over N raised to the NT. So here, when we're talking about compounding, we would then have to plug everything in. So this would be 4,000 times 1 plus 0.088 all over 2 raised to the 2 times 4. So here we would have 4,000 times, you would work inside out. So we would work on this inside piece. So you would take the 0.088 and divide it by 2 and then add 1 to it. So 1.044, and then 2 times 4 gives you 8. You would take this 0.044 and you would either raise it to the power of 8 or you would multiply it times itself 8 times and then multiply that by 4,000, and you end up getting $5,645 as your result. Alright, here a couple invests $7,000 into an account paying 5% compounded monthly. How much is in the account after 10 months? Okay. So here again, your P is going to be what you have, which is the 7,000. We're told the rate is 5%. We're told you're compounding monthly, which equals 12, and then your T is 10 months. So again, there's a couple things that we need to look at. First, we have your rate here, which is 5%. Again, we have to divide that by 100, so we get 0.05. And then my time was given in 10 months. So in order to get 1 year, we remember that there's 12 months there. So this is going to be the same as 10 over 12 as a fraction. It can also be 0.83 repeating as a decimal. Again, I highly recommend using the fraction form and not the decimal, purely because this is a repeating number. But of course the choice is up to you. So here again, we want to know how much is in the account. Again, it's P times 1 plus R over N to the NT. So here this is going to be the 7,000 times 1 plus 0.05 over 12 raised to the 12 times 10 over 12. Now if you look very carefully here, notice the two 12s are going to go away. So this here is going to be my 7,000 times, do the inside, 0.05 divided by 12, and then add 1. So 1.00416 repeating, raised to the 10th. So once you have this value in your calculator, I would raise that to the 10th, or you multiply it times itself 10 times, and then at the end multiply by that 7,000, and you should come up with $7,297.20 in your account. So those are just two quick little examples on compounding interest based on the information that has been given. So if you have any questions, please let me know. Otherwise, sit back, relax, enjoy yourself, and I'll see you next time.